Hello, welcome to Convergence. My name's Michael Doran. I'm a California attorney. I've actually conducted trials where I've had to qualify witnesses that are experts to testify. So what you have to do is you have to talk about their history and what their area of expertise, and then the judge has to prove whether that person is an expert. So here I am, an attorney, not an expert, but not a scientist. I have had, in college, I've had physics. In the military, my MOS or my job involved electronics. And I trained for months and months. I've had circuits. In college, I've had a number of things that would qualify me to talk about radios, I guess, military computers, sending artillery rounds downrange and putting it around in a coffee can 5 miles away with a computer assistance. I've had secret clearances in that regard about the military equipment. But, you know, do I have a very specific degree? And the answer is no. I'm testifying in a way. I'm talking to you as an expert, but I probably couldn't qualify myself as an expert in court to talk about this. But as I say that, there's a real problem here in that I'm formulating a model or an idea of how things work, but science is a deductive process where you break things down into smaller and smaller pieces, and then you have a small idea and you test it, and then you build bigger ideas and you put them together. And that's what the idea of convergence is that technologies are advancing, and then as they advance, they come together. So for instance, in this particular area, I've been talking about undulation seen in the null data set, which is surface winds. And what the really interesting advance in spatial computing is that you can look right on your cell phone, you can toggle all around the world and see what the surface winds are, and then as you toggle and it blurs, and you can see these undulations clear as day right on your cell phone. And anybody can do it. Anybody can go right on their cell phone right now and see where this electrical influence on cloud dynamics is occurring, where the cloud microphysics are affected by things like space weather or carbonation in the oceans or a fire out here in California. So all those different things add to the dynamics, but you're starting to be able, because of technology, to see these things with your own eyes. One of the more important recent discoveries has been that with space weather, which again is now being monitored, the technology is improving. We have a comparable data set to see where things are coming, and we're seeing that La Niñas occur with this particular version of the solar cycle. So in the past, if you were talking about the solar cycle, you just talk about the sunspots. But now we've learned that the sun has a magnetic cycle that it goes through that actually creates the sunspots. And one solar cycle that we're seeing, it has a particular polarity, and then the polarity reverses, and then we get another solar cycle. So the entire cycle from start to finish, which has this that produces the sunspots, is actually 2 cycles. And why is that important? Well, because another input, which is also electrical, is cosmic rays. And cosmic rays, you can think of them, they're kind of neutrons, but they're mostly protons, is the way I look at them. And they have this influence on the Earth's magnetic field. And the past 4 years or so, from again, a separate data, separate expertise really, would be required to just talk about this. So what I'm doing is I'm kind of putting it together. And I'm putting together this central idea that Albert Einstein talked about. He talked about among the most difficult problems, this is an easy problem, in all of physics is the Earth's magnetic field. And I'm saying that it's the most difficult problem in biology because life itself comes from this, grew complex from this, and to this day now is a part of producing this dampened condition that we call climate. And now back to cosmic rays. So since about 2017, there was a dip just after 2017, but getting into 2018, 2019, and then to about 2021, cosmic rays were extremely high. And it wasn't just a part of this single solar cycle, but it also has to be seen in the context of what the sun does, because what the sun does is its activity blocks cosmic rays. So when the sun gets relatively quiet, there's still coronal holes and things like that, but when the sun gets very quiet, then the buffering of these cosmic rays that come in from space decreases, and then the cosmic rays have a very strong impact on the circuitry of the Earth's magnetic field and the global electric circuit. It starts to have an effect on lightning totals, and then ultimately what storms are doing. And so this period of time when we start to look at what storms are doing and what fires are doing, fire behaviors, we have to look at the fact that it's all in the context of these elevated cosmic rays. And this is, again, this data that's showing, that's basically new. The Cosmic Ray Station at the University of Ula, OULU, Sadenkela Geophysical Observatory, and you can get this link through SpaceWeather. There's a little, spaceweather.com has a little place where you can get for further information, and it takes you right to that neutron monitor database. But again, this when I talk about 2 solar cycles, this then becomes very interesting, because you can go back in time to, say, the Dust Bowl in the United States and the horrific 12 million deaths of Ukrainians in 1932, 1933, and see that it lines up when there was so you go back 22 years, 22 years, 22 years, and it brings you into the low 30s. So that was also another time of when these cosmic rays were very high, as the solar buffering or protection, the sun's protection with its own magnetic fields, and was at a low. And one of the reasons that you can go back 22 years rather than back 10 and a half or 11 years is because the magnetic orientation of the sunspot cycle starts to matter in how these cosmic rays are deflected, or it affects the actual result of cosmic rays coming in, the orientation of the Earth's magnetic field. So it goes through, you have a cycle where the orientation is, the magnetic orientation of the sun is one way, and then it peters out, and then the new cycle comes in and it has a different reversed orientation, and then that affects how particles and the manner in which things come from the sun, whether it's solar winds or whether it's X-rays, and what the magnetic field is doing from the sun, and then it affects how cosmic rays are coming in and how what the level of cosmic rays are and the direction and orientation. Now I'm giving all this background. Nobody, I could interview on trial looking for experts on there. There isn't any experts on this. This is because it's not a scientific reductionism type of approach. I'm giving you a model. It's going to be helpful for people to understand who are experts, but I'm not an expert. It's more of an argument, like a closing argument. It's analogous. Really, it's a cultural problem that we have within the way that we deal with, litigate or solve problems, legislate against things. So I know I'm bouncing all around, but let me give you an example of that. If we decide that there's some old growth we want to protect, it doesn't have any right. That a 2,000-year-old redwood tree, a giant old growth tree, has no right to exist. If a person owns private property and that tree is on that property, that tree's done. I mean, that person can cut it down. They own the property. The old growth tree doesn't have a right. And there are some people that are arguing for rights to give certain things in nature that kind of like in our history, women were considered property and had no rights. And then eventually they were given a person status and rights to vote and so forth. You could say the same thing about corporations. I'm just giving you our legal history where we're standing to do anything about situations. You didn't have any right to go into court and say, oh, you know, I'm a corporation and I have rights. That didn't exist until the law evolved to give corporation standing to do things. And the same thing is with trees. So if you were a 2,000-year-old old growth tree, you had no right. I'm not saying that things like that there wasn't acts that gave power to do things for the government to protect things. The Endangered Species Act, for instance. But there is no legal standing for a 2,000-year-old old growth tree. And part of the reason that I can say that is only about 5% of the redwood forest here, 3 hours drive from here, remains. It was all harvested. And, you know, these things are happening so fast that a lot of environmentalists, as they watch South America being converted into farmland and burned away, where you have these natural habitats that are, you know, irreplaceable, that people are starting to talk in the legal community about giving environmental rights to certain things, whether it's types of trees or other things that we really should be giving some standing to in our legal system, and we don't at this point. So that's the context that here I'm making an argument that the Earth is alive and that life itself comes from modulating or dampening the Earth's magnetic field. CO2 is interesting only in clouds in the context of electrical fields in this regard. And I'm starting to talk very specifically about events that are occurring or that have occurred. And this is a redo of what's called a campfire. I wanted to talk about that, but I decided to pull back a little bit and be a little bit more general about this approximate 4-year period of time where we had very high cosmic rays. It's starting to come down a little bit. We're still having fires. There's an active fire right now as of today. But the campfire was interesting because in this context, after the October 31st record lightning bolt was observed with the new GOES satellite. Again, I'm not a satellite expert, but I'm putting these technologies together that we have, they're converging and they're showing us a very clear picture of what was happening in 2018 with this high level of cosmic rays, that you had this record on Halloween in 2018, you had this record long, 400-mile long bolt of lightning across South America. Why is that important? Well, because lightning, when it occurs in South America, it creates Schumann resonances, and there are conductive pathways that depend upon the ocean temperature, the amount of carbonation that the oceans have. And that time of year, even though it's November, some of the warmest temperatures along coastal California occur in the late fall. And so you have very active lightning that's occurring in South America that basically electron precipitation, currents, these Schumann resonances, these undulations that I've been talking about, connect to California. And it was in that context that you had a slowdown of the solar winds. And as that occurred, solar winds not only will buffet away cosmic rays, but they will also disturb couplings, electrical couplings that occur, electrical organizations that produce these cloud and really fire behaviors that get organized when you're talking about carbonation, supercooled droplets at elevations or at altitudes is probably the better word. And so you have very cold conditions and electrical fields and cosmic rays enhancing those fields. And that, in my view, really affected these very hard winds that come, and they were directed through a canyon. And these winds are offshore, or they come down the plateau and then they move towards the ocean, as opposed to coming from the ocean and having moisture and coming up where the rising air mass condenses and maybe brings rain. It's the opposite, where you have very dry air coming down and dropping down, and it's cold. These winds are very, very, very dry. And the power company had some kind of a small fire, and then like within an hour it exploded in size. And people there was no planning for it in Paradise, California, because this is a new phenomenon that's occurring, and many, many people died. And so that was the campfire. Again, people have to understand there's this electrical context, and it has to do with lightning in South America, enhanced by cosmic rays. And then further, it's a biological complexity, electrical and biological complexity. So things like fertilizers that we're using on our crops now, things like dams which upset methane hydrates, and how much carbonation is in different places at different times of the year. And is the reason I wanted to talk about this more generally, because I can get in now and expand this discussion into the 2019 tropical storm season, and then the 2020 tropical storm season, and the horrific fire season that we had here in 2020. And that's because now that we're just talking about a high level of cosmic rays, we can also talk about El Nino and what it really is, what El Nino really is. The end of the La Nina state occurred strangely with yet another tropical storm. And let me see if I can explain. 2019 was, the tropical storm season was the year there was a Category 5 over the Bahamas. And it just stayed there. I mean, it didn't move. Didn't move. Category 5 didn't move. These tropical storms are the low impedance events on Earth. And this particular Category 5 that was in 2019 and over the Bahamas was not in the Gulf of Mexico. It was situated where there's close to where there was lightning in South America, and shortly after we saw this horrific fire in California in November of 2018, and the record lightning strike that occurred in South America on Halloween 2018. So less than a year later, we get back into the season starting from when the spring begins in South America, when you get cold fronts coming down from Antarctica, and it's creating this lightning. And it's, again, these are large-scale, low-frequency events. And this is powering this complexity in the Bahamas area. And it's decarbonating the ocean there. It's taking carbonation out of the ocean, and it's organizing where the circuitry is. And it was so stable in terms of lightning in North America and lightning in South America and lightning in Africa over the intertropical convergence zone. Right in between all three of these, you have this low impedance place, basically where currents can go to, and it's altering cloud microphysics, and it's allowing this storm to stack. And it's one of the reasons why El Nino exists, because you can say that that colder oceans hold more carbonation, and so it's kind of a paradox that the warmer oceans will have more latent heat for storms, but the colder oceans can hold more carbonation. And then there's feedbacks in terms of the storm itself will cause colder oceans to upwell, and it'll be nutrient rich, and it'll allow for phytoplankton blooms, and again, more carbonation. So what I'm talking about is very complex and interdependent. But what happened basically after this storm in the Bahamas, this category storm that just sat there forever, is it changed the overall picture, finally, that we had been seeing in the context of this cosmic ray high level, to where a La Nina wind started to appear in the Pacific. And then, again, because of this electrical complexity, it really doesn't start to appear and be a teleconnection until the wintertime, say late December, January, February, March. And that's because once the sun and the earth are oriented so that the southern hemisphere is pointed towards the sun as the earth orbits the sun, you start to expose the Southern Ocean as a common, and then the charges around the world break into quadrants and organize positive charges, negative charges, positive charges around the world. And there's this gap in the Pacific Ocean between land, where most land is where lightning occurs, and where 90% of lightning occurs over land. And there is no land in over the vast Pacific. Yet, because of this common conductive area of the Southern Oceans, it allows charges to organize and for lightning to occur in the Pacific during the winter, during that time, because again, the Southern Ocean is a common. And that organization then occurs in the context of whether the eastern or the western part of the Pacific is warm, is allowing for carbonation and decarbonation to go into clouds and affect the cloud microphysics. And then those clouds and the lightning that they produce has an impact on Schumann resonances and creates teleconnections for more rain. And what happened was that Category 5 storm that went on and on and on and on affected the pattern enough to produce an El Nino state in 2019. And during 2019, we did not have the number of fires that we had in 2018 and in 2020, which was the record year. But 2019 did have that tropical storm over the Bahamas that stood. The next year, after the El Nino died down, was the most active tropical storm season on record. And again, it has to do with combining a La Nina with high cosmic rays, with what we're doing to our rivers with fossil fertilizers, what goes to the nearshore ocean in terms of carbonation, and when it goes there. I just saw that Greenland is very actively melting, but it's not melting at the normal peak of when the peak of the melting season is. It's delayed a little bit. Well, there's delay that is occurring to carbonation in the nearshore oceans by all the dams that we've built. So during the rainy season or during when rain comes, that's not when rivers are releasing and creating higher carbonation to the nearshore oceans. The dams capture that water and change its character, change the sedimentation load, change the carbonation that they have, but it delays when that occurs. And so all these different things that humans are doing that affect conditions electrically are what we need to start looking at. And so when you talk about the most active, these super fires that we had in 2020, we're having a little bit less of them because cosmic rays are down. You can't look at this without looking at what the electrostatics are and what they were in 2020. And then when you look at the electrostatics, then you can say, these are the things that humans are doing that are causing phytoplankton blooms, dead zones, red tides, different things in different places that affect carbonation when surface lows go by. And for California in 2020, you have these clouds that are like tornado clouds in Tornado Alley over fires that the carbonated smoke creates above them and creates these giant vacuums. You have electrostatics that support trees burning in such a way that they lift and they float past fire lines. They're unfightable. The California fire departments CAL FIRE can't do anything about it because the fire behaviors are such, helped electrostatically so that they burn and burn and burn, and there's nothing that can be done. And we need to start talking about what the mechanism is, when this occurs. It helps forecast skills. Final thing I'll say about 2020, I've got just 20 seconds here, is another record lightning bolt was seen in just above the dead zone in 2020. This one even longer than the one in South America, and it was no coincidence that we had a record tropical storm season and a record fire season. Thank you. Please like, please subscribe.